So this is an example of electric bill where you have details of your charges. Usually the utility will have a summary of the charge where they tell you what your total bill is and what the total kilowatt hours we used were. But we're going to go through the different sections of the detailed part of your bill. And there are three main charges that are going to be on your bill. Sometimes they'll be broken down into different sections and different amounts, but let's talk about them in detail here. Your energy charge, the amount of energy used in kilowatt hours. Now sometimes you may have this broken down into an on and off peak rate. So your utility should have the information so you'll know when your on and off peak periods are so you can identify them. When you're trying to figure out about how much you're using on and off peak and how you can possibly shift energy from an on peak period to an off peak period, you'll need to have those periods identified for you. The next charge we'll talk about is the demand charge. Based on the highest power requirement, averaged over any half-hour period during the billing cycle, and this is measured in kW. This charge covers the monthly demand costs and costs related to the sub-transmission system and substation upgrades and maintenance. Now this may also be on a time of use rate, so you may have a demand charge that's for an on-peak period and for an off-peak period. You'll need to check with your utility to find out. Now the utility charges a demand charge because they need to have a certain amount of capacity to be able to supply power that you need. And in the case of our water tower analogy, it's the size of the ladders and buckets and stuff that are needed. But it's really the size of the transformers and the wires and the substation that's needed to supply power to your location. Another charge on your bill that you may have is reactive demand. This charge is based on the power factor, which is a ratio again between the kW demand, kilovolt amps reactive, or your kVAR. Okay, so this is the difference between what is used and what is returned, as in our water tower analogy. So how much of the bucket was emptied on each trip. Typically you're billed for charges above a specific threshold level that's related to your average power factor. For example, many utilities use about 0.85 power factor. They don't charge you any reactive load if you're above that. If you're below that power factor, then they're going to charge you additional. Two other charges we need to discuss on your electric bill are the transmission charge. This charge includes the scheduling, the dispatch, the system control, reactive load control or supply, regulation, and load following costs. So included in this is the size of the buckets and number of ladders and people that are needed to transport that power, which again are really the wires, the wire size and things like that. Now the facility charge is the average of the two highest monthly demand, or kW, for the last 12 months. This includes the shared primary and secondary wire, as well as distribution transformer costs. Again, like we were talking about, the size of the buckets and ladders in the distribution system. So let's look at an electric bill. In this case here, you have a number of different charges on here that's based on your usage. So there's a system usage charge that's based on your total number of kilowatt hours used during that period of time. Now the system usage could be for the poles and wires, and different utilities will break those down in different areas. So there's the on-peak usage and an off-peak usage, and those are at different rates. The off-peak usage happens to be at 6.962 cents per kilowatt hour, and on-peak is 8.042 cents a kilowatt hour. Now you also have on and off-peak demands. In this case, this bill has an off-peak demand of 1000 kW and an on-peak demand. This is usually broken down to different sections. The first 30 kW in this case is at one rate, and the following 1037 kWs is at a second rate. So it has two on-peak demand readings. This bill also has a reactive demand charge. This one had a reactive demand of 616 actual kVARs, but they're only billing you for 189 kVARs. So that's that difference of, in this case, probably an 85% power factor. Now you have a transmission charge at your peak of 1067 kW, and it's at 78 cents a kW. You also have a distribution charge, which happens to be based on your facility capacity. Now, many utilities will take your largest readings, in this case, a capacity reading for each month over the past 12 months. They'll take your two highest readings and average those together to have that be your distribution charge. Make sure you check with your utility to find out what those facility capacity charges are and how they're based, because each utility may have their own way of doing those calculations. Now in this case, this bill here has some more information on it. It's showing you your average kilowatt hour use per day for different months. So right here you can get an idea of your energy usage over the course of the last year. You can see that in this case here, your winter bills are lower than your fall and summer bills. In this case, this facility probably has gas heating, so your electric bill usage is down in the wintertime. Another important thing to note on here is the number of days of service of this bill. In this case, this bill happens to have 33 days of service. It shows you here when the meter readings were done. So it shows you the meter reading that it started with and the meter reading that it ended with. And it also has a meter multiplier. The meter multiplier reading here is due to the way the meter is recording information. It has current transformers and potential transformers. It's not reading exactly all the energy that's flowing through your system because the size of the metering would have to be very large to do that. So there are some step-down transformers that take samples of the voltage and the current and convert them using a meter multiplier into your actual energy usage. Again, this is showing you some information about your bill where you have a period ending September 2005 and comparing your 2005 to your 2006 usage for the same month. So it's showing you here the average kilowatt hours per day went down from September 2005 to September 2006. If you want any more detailed information about your utility bills, please make sure you check with your local utility. This is the end of the Interpreting Electric Meter Data, Section 2, What is your energy bill all about? If you haven't already, please go to the Better Bricks website and go through the other 4 parts of the training.